Okay, I think we are ready to start. Well, in the first place, welcome all of you. It's a big pleasure to introduce this workshop regarding upcycling bioplastic of food and drink packaging, where we will be introducing 3 sustainable European solutions, but we will also have the opportunity to listen 2 speakers external from the consortium that they will speak about the bioplastic sector and also for the plastic policies in the framework of the European Union. So welcome all of you. Let me first talk a little bit about the agenda that we are gonna see. In the first place, we will be presenting the speakers. My name is Pablo Morales Moya, and I will be together with Mara from NEIA moderating this webinar. I will be in charge of the moderating, while Mara will be in charge of answering your questions or addressing your question to the correct project coordinator or a speaker. Then we will have the opportunity to listen Hasso von Pogrel. He is the managing director of the European Bioplastic, and he will be introducing the bioplastic sector. Then we will have the opportunity to listen Alexandra Brankovic. She's a researcher at the Institute for Development and Innovation in Belgrade, and she will be introducing the plastic policies. And then we will have the opportunity to listen Cristiano Barrone, who will be introducing UPLIFT Project. He is the project coordinator at the University of Aalborg, and at 11:20, we will have a 10 minutes break. After the break, we will have the opportunity to listen to another European project, PRESERVE, introducing by Aldo Ramirez, project coordinator at Iris Engineering. And last but not least, we will have the opportunity to listen to Fuensanta Monzo from CETEC, who is the project coordinator of UPET project. We will conduct a breakout session, a very funny activity through Mentimeter. So for the audience, make sure that you have your mobile with you, because we will be conducting a very interactive session through Mentimeter. And then we will have the wrap-up. We will have an open discussion revolving around the importance of clustering. Of course, at the end of each speaker, we will have a 5-10 minutes block, just in case you want to ask something to each speaker. Some webinar notice, please. This session is being recorded. Make sure that your microphone is mute, so we avoid to have audio issues. Use the chat function to enter your questions. And as I said, this is an interactive session, so please participate on Menti when it's required, and also feel free to ask anything or something that you may be interesting for you in the chat. Regarding the moderators, as I said, my name is Pablo Morales, Communication Manager at Sustainable Innovations here in Madrid, and I'm also the Communication and Dissemination Manager of UPLIFT Plastic Project. With me, we have Mara Menela. She's Content Analyst at NEIA and Communications Manager at PRESERVE Project. So I don't know, Mara, if you want to say something, if you want to introduce yourself.
Well, good morning, everyone. I will be moderating the chat and the questions. So I'm really glad that we managed to organize this interesting workshop, and thanks to all the speakers who joined us today. And I hope you enjoyed the workshop as well. So Pablo, if you want, we can start.
Okay. Before I start, I would like to make a brief introduction about the speakers of the workshop. In the first place, as I said, it's a pleasure for me to introduce Hasso. Hasso is the current managing director at European Bioplastics since 2009. He has a senior experience as he has been also managing other companies such as Federal Association of the German Medium and Large Retail Enterprise, and acting as a head of department for foreign Affairs at the Association of the German Construction Industry. Today, he will be opening the session of the sector of bioplastic. So welcome, Hasso. I don't know if you want to say something. Say hi.
Hello, I'll say something afterwards.
Okay. Then we will have the opportunity to listen to Alexandra. Alexandra is researcher, as I said, at the Institute for Development and Innovation in Belgrade. She has also worked as a consultant in several institutions, such as the World Bank and the Westminster Foundation for Democracy. And today she will talk about the plastic policies in the European Union framework. So welcome, Alexandra, also. Then Cristiano, he's the project coordinator of UPLIFT at the Aalborg University. He is working as an associate professor in fermentation technology at the Aalborg University. He has a solid background working in other Horizon 2020 project and FP7 project. And additionally, he has worked as a postdoctoral researcher at the Technical University of Denmark and for the University of Aalborg. So welcome, Cristiano. Aldo, representing PRESERVE, the project, we will have the opportunity to listen to him. He's the project coordinator of this fantastic initiative, and he is actually project and innovation manager at IRIS Technology Group. For more than 2 years, also worked as a researcher in the field of nanomaterials for environmental chemistry. So welcome also to you, Aldo. And last but not least, Fuensanta will be introducing the project UPET as he's the project coordinator. She has an amazing background in CETEC, where she has almost 30 years of experience in charge of the laboratory, quality assurance, and also research and development processes. So welcome, Fuensanta. And then, as I said, the first short talk will be introduced by Hasso van Pogrel. So Hasso, the floor is yours if you want to share your screen.
I'll give it a try. Is it working now, or do I have to switch screens again?
It's working. We can see the top line of your Mac.
You can see the screen. Is it the way it should be, or do you see the one with the remarks?
We see the remarks from,
Okay.
it's okay, but if you want to try again.
Yeah, I'll try to. Now, did it work now?
We see the presentation mode. I mean, with the notes.
Oh, that's the one I wanted to avoid. Okay, let me try it.
Now it's perfect.
All right. Okay, thank you very much for the nice introduction, Paulo. My name is Hasso van Pogrel. I'm the Managing Director of European Bioplastics. Since I'm not quite sure who is listening and how much knowledge about bioplastics you have, for those of you who are already familiar with bioplastics, please bear with me. I will say some simple facts about bioplastics, which for you will probably be very well known, but for others maybe not, so please bear with me. Okay, maybe a few words about our association before that. We are roughly 30 years old by now. We started as a purely German association, but in 2005, we renamed ourselves to European Bioplastics, taking up members from outside of Germany, even outside of Europe. And the common denominator is the interest in the European market. And the scope was widened from purely biodegradable plastics to bio-based and biodegradable, respectively bio-based and non-biodegradable plastics. We are, of course, a lobby association. That means we try to lobby to get favorable legislative environment in Brussels for our industry. And if we can't achieve that, at least try to avoid unfavorable legislation, which is tough enough as it is. And here's a look at our members. We have roughly 70 members today, most of them from Europe, but also quite a few by now from outside of Europe, and they cover the entire value chain, starting from renewable raw material producers over plastic producers, converters, users, and brand owners. And like I said, roughly 70, and I'll won't go through them, just for you to see if you want to have a look at it later on. We have a strong network in Europe, first of all, with other bioplastics associations, national bioplastics associations, where we lead a regular meeting with them, but also with the so-called European Bioeconomy Alliance, which is a bunch of federations that are active in the bio-based sector, of which we are only one, but an important one. And of course, we also have an international network, which, however, is, only occasional, that we have contacts with different associations like the Australian Bioplastics Association, but also the Japan and others. Now a few words about bioplastics, what they are. So according to our definition, bioplastics are bio-based, biodegradable, or both. That means bio-based means they're coming, at least in part, from renewable resources. Biodegradable, unless otherwise specified, normally means compostable in industrial composting situation, and both is, as it says, both facts. Here's a little overview of what kind of polymers you find in which sector. So if you look at the only bio-based, non-biodegradable, you often find the so-called drop-in solutions. Those are bio-based versions of conventional plastics like polyethylene, PET, and others, which are only made with bio-based and renewable resources. Then you have the largest sector of biodegradable and bio-based plastics, which are often the new polymers like PLA, PHA, and starch blends. And then you have a very small amount of only biodegradable but fossil-based plastics like PBAT and PCL, but those are today also possible to be made out of renewable resources. Only the expenses often prohibit this being taking place in a large scale. One thing that has to be clear, bio-based does not mean also necessarily biodegradable, and vice versa. So as I said, you can have a biodegradable polymer which is made from fossil resources, and you can have a bio-based polymer which is not biodegradable. So these two things should not be mixed up. It's very important to keep them apart. One word about what bioplastics are not. You often see or hear about the so-called OXO biodegradable plastics, for example. Those are conventional plastics which have an additive added to them, which at the end of the day only makes them fragment but not biodegrade. So this is also very important. Biodegradation should happen according to a right and correct accepted standard like the EN 13432, and only then can you talk about biodegradation. Otherwise, we're only talking about fragmentation, which actually is worse than non-biodegradable or fossil-based conventional plastics. A short outlook on the market development. So this is an overview of the year 2020 to 25, which of course is only a forecast. But in 2020, we had roughly 2.1 million tons of bioplastics on the market, which is a bit below 1% of the complete plastics market. And in 2025, we're expecting a rise to about 2.8 million tons, which is an annual average growth rate of 6.3%, or a total growth rate within those 5 years of 36%. So we are still a very small sector, but growing steadily. This is an overview of the bioplastics by material type. You can see that the higher share of almost 60% are bio-based biodegradable plastics. Only, like I said, PBAT, so roughly 13.5% are non-bio-based biodegradable plastics. And the other side is roughly 40%, which are bio-based, durable, non-biodegradable plastics, with PA and PET leading. Like conventional plastics too, almost half of the bioplastics go into packaging, so roughly 47%. And other consumer goods have a big part. Textiles are growing, and also agriculture and horticulture, but also automotive and other sectors are growing. A little overview of the capacity by market segments. So here you can see that, for example, flexible packaging is dominated by biodegradable bioplastics, but of course also polyethylene, which is a very flexible material, still is very strong in the flexible packaging market. And it's a little bit the other way around in the rigid packaging. Here you have quite a bit of, for example, PET, mostly the bottles, which you find in the rigid packaging. And then if you just, for example, look at agriculture and horticulture, here you see practically only biodegradable polymers, which of course makes sense because a bio-based version of already existing conventional polymers in the agricultural sector doesn't make any sense. It's only more expensive and has to go through the same procedure of recycling as the conventional ones. Just a small thing, because we're often faced with the allegation that making bioplastics from renewable resources is a threat to the, food and feed sector. This is absolutely not the case. The amount of arable land or agricultural land you need to grow the crops needed for bio-based plastics is so infinitesimally small that there's no threat whatsoever to food and feed. Now, probably most of you know this slide here already. It's from the Ellen MacArthur Foundation. And this shows that the recycling of plastics packaging is a very big issue. And obviously recycling is not taking place in nearly as much as it should be. So we're talking about roughly 14% of plastics packaging being collected for recycled, of which only 8% are actually being recycled and 4% are still lost. And the other parts of the 86% are either ending up in incineration or in landfill, or even worse, in the environment. The European Commission, with its plastic strategy, said that by 2030, all plastics packaging has to be reusable or recyclable in an economic way. But obviously, this is where we have the biggest issue, because already today, much more packaging is at least technically recyclable than is being recycled. And obviously, the economic part is playing a big role, because especially for small sized packaging, it is not worthwhile to collect it, sort it, clean it, and then to recycle it. So we have to find different solutions to make plastics recyclable. And if that's not the solution, then to find new recycling ways, which is obviously part of the discussion we're going to be having today, to find new solutions to recycle plastics. So bioplastics are much more complicated than you would think. Once you get into the nitty-gritty of bioplastics, you see the level of information is very low, unfortunately, also in the European Commission, who have a lot of, mixed information coming from all sorts of sources. And often this doesn't add up to, to a good knowledge base. And this is why we as European Bioplastics, we try to convey as much information as possible about bioplastics. but unfortunately also when it comes to bioplastics and information, we often have greenwashing, and this is something that we need to definitely avoid to make sure that bioplastics do not get caught or be, how you say, perceived as greenwashing. So there's still a lot of myths and misconceptions that still prevail. I'll be going through just a few of them, and I'll be skipping a few slides, but I left them in the deck just in case somebody would want to look at them later on in more depth. And if you have any questions, please feel free to contact me at any time. So here we have the one very often myth that bioplastics are often perceived as biodegradable in general, so also the bio-based and non-biodegradable ones, and that they are seen as a solution to plastic litter, especially in the marine environment. This, however, is not what bioplastics were made for. Bioplastics do not belong in the environment, period. So packaging should always be designed for reusability or recyclability. And when we talk about recyclability, we need to take into consideration all kinds of recyclability, that is mechanical, organic, so composting, and chemical. And biodegradability should always refer to a specific environment, time frame, and so on, and be third-party certified in accordance to acknowledged norms with pass-fail criteria, which, for example, the OXOs are failing to supply. I'm skipping this one. This is already very detailed about the EN 13432. Then here we talk about the certified accord, also again about the 13432 and the allegations we've received that often, because the standard talks about 90% biodegradation, people think 10% of this will not biodegrade, but this is not the case. The case is that a lot of the carbon that is in the product is converted into carbon dioxide, but not all of it. Some of it is taken up by the biomass, and this is not measured. So the 10% is the minimum that is ending up as carbon in the biomass. Then another allegation we face very often is that bioplastics disturb mechanical recycling. And here we should be aware, like I said at the beginning, the bioplastics are still well below 1% of the overall plastic production, of which 40% are mostly drop-ins. So these definitely do not pose any problem with recycling. And of the remaining 60% of the less than 1%, these are intended for bio-waste collection. So they shouldn't be ending up in the recycling stream anyway. And people buying, for example, those bags will not put them into the recycling bin anyway. So, and then before you do recycling, you have sorting techniques, and the near infrared is a very well working technique. So the chances of bioplastics, especially biodegradable plastics, ending up in the recycling is quite close to zero, and up to 3%, in some cases even up to 10% contamination poses no problem. So this is not really an issue. Then something against biodegradable plastics always said that if you biodegrade plastics, you are actually wasting the calorific value of these plastics, which could be better used in incineration. And that per se is a correct statement, but we need to be aware that these biodegradable plastics are not there to be composted per se. They're used to collect far more compost than you would be collecting without the use of biodegradable plastics. And therefore, you just separate a lot of bio-waste today ending up in the residual waste, which should end up in the bio-waste. So in this case, composting is the better solution. This is again another detailed one. I'm going to skip that one as well. Then I already mentioned that before, that the competition for land use is very little, and that therefore the making of bioplastics with renewable material poses no threat to food and feed, and therefore shouldn't be hindered. And finally, and this maybe also leads me over to today's meeting, if we look at the impact Europe actually has on the waste ending up in the oceans, for example, which is the biggest part why the whole legislation around bioplastics is taking place in the first place, is only very little. So I'm not saying that we as Europeans shouldn't take up this issue and find good solutions, but we need to think beyond of this and say we need to help the rest of the world with the solutions we come up with in order to really have an impact. If only we Europeans have a good way of treating waste, this will not have the impact that we need to really keep our environment safe and clean. And therefore, I think the objectives of the projects we're having or we'll be talking about today is something that we definitely need to develop and then to really help promote in other countries as well. So that would be it from my place, and I would be very happy to see with the one or the other of you at our conference, which will be taking place in Berlin on 30th November and 1st of December this year. And I'm happy to take any questions you may have. Thank you.
Thank you so much, Hasso, for such an amazing presentation. Next presentation is Alexandra, but before moving Alexandra, I would like to ask Mara if we have any questions or encourage the audience to ask any question regarding Hasso's presentation.
We do not have any question right now, but feel free to write in the chat and I will read them. Also, as you see, Hasso left all the contacts, so also you can take note of that if you want to revise again the slides or ask very specific and detailed question directly to Hasso van Poorgel. So thank you.
You're welcome.
Okay, if there is no question, I think we can move to Alexandra's presentation. In case that there is further question, we will have at the end of the workshop a Q&A general question in case you want to address any other question to Hasso. So Alexandra, the floor is yours.
Thank you. Thank you very much. I'm Alexandra Brankovic. I'm engaged as a researcher in the Institute for Innovation and Development in Belgrade, and we are working at the UPET project, participating in the social sciences and humanities aspects of the process. And I will present a short overview of the plastic policies at the European Union, because we are preparing this as part of the policy overview and policy review that we are preparing within the project. First, I would suggest to put everything into the broader perspective and to see what is the place of plastic policies within the European framework. So here is the overview of the table of EU competencies as specified by the Treaty on the European Union. And plastic packaging is for the most part related to this area here, waste, that is the environmental competence of the European Union. We will discuss this in more detail later, but basically why this is within waste, because of these all the pollution and the contamination issues that require proper management of plastic packaging and proper recycling, improved recycling of plastics. Also, a substantial portion is related to the safety of packaging that is in contact with food. So these areas are tackled by the competencies related to consumer protection and food safety. And as perhaps mentioned, bioplastics, there are still no specific legislation at the EU level related to bioplastics, but this is under discussion and under development currently. So we can expect that some policies and legislation would probably be enacted at the EU level in the near future. What is the place of plastics within European economy? Plastics industry is acknowledged to be very important for the European economy. However, because of all these issues related to plastic waste, to plastic littering, especially of the marine environment, European Commission has put forward a requirement or a vision, as they call it, for the new plastics economy. This economy should be smart, innovative, and sustainable. So emphasis is put on the need to have durable products that can be used repetitively and that can be efficiently recycled. And these requirements are imposed at the very beginning of the process, not only related to the waste management, but the design, a lot of requirements related to the design of products would be put forward in the future, so that at the very beginning of the production stage, the products are made in such a way that they can be easily sorted, that can be durable, and that can be easier to recycle. Also, the vision contains requirements related to the decrease in the consumption of fossil fuels in the production of plastics, thus adding to this sustainability criteria. So different measures are envisaged. I will discuss them in more detail when we talk about some legislative requirements, and generally this is all contained in the European strategy for plastics in a circular economy. When it comes to the current EU legislation, these are the most important pieces of legislation that deal with plastic packaging. For the most part, these are the Waste Framework Directive and the Directive on Packaging and Packaging Waste. Also, we have two directives that are particularly aimed at single-use plastics. And we also have several regulations that are related to the materials, and in particular plastics and recycled plastics that are in contact with food. So let's see what are European policies related to plastics that is used as packaging. A lot of general requirements that apply to all packaging is also applicable to plastic packaging. Definition of packaging is very important. Why is it important? It's a very complex and very comprehensive definition that would probably not fit, discussing it would probably not fit into these 20 minutes. I will not go straight into details, but these definitions are very important because they help distinguish in which cases plastics is considered as packaging and in which cases plastics is considered as part of the product and not the packaging. For example, I will give one example. When you use coffee capsules, they are considered packaging if they are left empty after you use coffee. And if the coffee content is left within the capsule, then it is not considered as packaging. And why is all this important? Well, because we have a producer responsibility for packaging, for plastic packaging, and we do not have producer responsibility for other plastic products that are not packaging. Well, I will talk about this in more detail later, but just want to point it here. Why is it important to distinguish whether some plastic is packaging or whether it is not? Because different responsibilities are applied to different types of plastics. Essential requirements on plastics are also contained related to plastics used as packaging, so that there are some limits on the weight and volume of plastic packaging. Producers are only required to use it to the extent that is necessary. The packaging also is required to provide adequate level of safety and hygiene to the products. The presence of possible hazardous substances is strictly limited. Design of packaging should be in such a way to facilitate the repetitive use and the easier recycling of products, and emphasis on the design, as I mentioned, is going to be exacerbated in the future. There are also markings so that different types of plastic packaging may contain different material labels that are prescribed by at the EU level, and member states should use these markings. And so these are some of the essential requirements. Another point that is very important is that extended producer responsibility is obligatory, or will be obligatory, for plastic packaging. This producer responsibility basically means that producers who place the plastic packaging or the products containing plastic packaging on the market are the ones that are required to organize the management of plastic packaging waste, or at least to cover the associated costs. This obligation is established to facilitate the better collection and treatment of plastic packaging, because we have one entity, these are the producers, that are specifically required to address these problems and to take more effort to make sure that the waste is collected, that waste is properly treated, and they can also influence the amount of plastic waste that is placed on the market and their properties by purchasing raw materials, those types of materials, and requiring proper design that can all lead to better collection and better recycling of plastics. So this is why the role of producers is very important. For example, in many EU member states, this producer responsibility is obligatory for plastic packaging. Not in all of them, but by 2025, all EU member states will be required to establish extended producer responsibility schemes for plastic packaging, and also the producers would be required to cover at least 80% of the costs related to plastic waste. We also have some reporting requirements imposed on member states, and member states then impose reporting requirements on producers. And these are basically imposed in order to collect data on how much plastics is placed on the market, how much of it is recycled or combusted, and so on. What is specific to plastic packaging is that certain limitations for some types of plastics are imposed. The background intention of these measures that have been put in place in the previous couple of years is to decrease the littering of oceans in particular. Basically, 10 single-use plastic products that are most commonly found on European beaches are addressed by these measures. And these 10 single-use plastic products are accounting for more than a half of total plastic litter in Europe, in European beaches. So these measures should hopefully have a substantial effect on the reduction of marine pollution. Among these 10 products, lightweight plastic carrier bags have been most common, so their use is required to be decreased. The European Union imposed the requirement on member states to undertake different measures. One specific measure is to stop providing these bags free of charge, which has already been applied, and they can also apply other measures as well. And the expected effect, the target basically, is that by the end of 2025, the consumption of lightweight plastic carrier bags should be confined to 40 bags per person per year. When it comes to other plastic, other of these 10 most commonly used single-use plastic products. SUP, or the Single-Use Plastic Directive, has been imposed. And this directive makes distinction between those plastic products that can be replaced by readily available alternatives and those products that cannot be that easily replaced. For the products for which there exist sustainable alternatives, such as plastic plates, plastic cutlery, plastic straws, also food and beverage containers made of expanded polystyrene, all these products have been completely banned. So they are not allowed to be placed on the European market starting from July this year. For other groups of products that are not that easily replaceable, different measures are put in place to limit their use. So they are not banned, but measures are put in order to limit their use and increase the recyclability of these products. For example, these products encompass plastic packaging for ready prepared meals that you can take away. Also plastic bottles, drinking cups, plastic wrappers, and similar products. Different measures are put in place. I will mention some of the most important from the viewpoint of plastic packaging. For certain products, labeling requirements are required to be applied as of July this year. For example, these labeling requirements are required for drinking cups, for coffee and other beverages. And these labeling requirements should contain information on the plastic content, on the proper disposal of this waste, on its impact on the environment, and so on. Another measure that will be applicable as of 2024 is that plastic bottles that we use will have to have attached plastic caps. So caps should not be able to be unscrewed anymore, that they should be attached to the plastic bottle as of 2024. And this is required in order to have both the cap and the bottle jointly collected and sent to further treatment. Another also very important measure that will be applicable as of 2025 is that the extended producer responsibility for these 10 single-use products, plastic products, would be broadened. So for some of these products, producers will also become responsible to cover the costs of the cleanup. That has not been the case so long. So this has only, if this waste, this litter on the beaches was collected, it was usually financed or done by municipal authorities. From 2025, it would be the obligation of producers to cover these costs. When we talk about plastics that come in contact with food, there are some general requirements applied to all materials that come in contact with food. So the European Union requires that certain requirements must be met. These materials, for example, must be such that if transfer of material to food occurs, this transfer must not pose any danger on human health, or the transfer may not cause, let's say, contamination of food. That is, that the composition or characteristics of food are changed. When it comes specifically to plastics, there are more specified compositional requirements for plastics in contact with food. So there is a list, compiled list of plastic substances that are authorized to be used to come into contact with food. Also, in case when new plastic substances are developed, there is authorization and application procedure envisaged so that this new plastic material can be used for food packaging. Migration limits are also specified, which refer to the maximum amount of material substance that can be transferred to food. For multi-layer packaging, there may be some exemptions. So, for example, the layer that is not directly connected to food may not be required to meet all these limits. And what is also important is that the EU provides guidance on the cases when recycled packaging can be used to for the packaging of food or to be in contact in food with general. This application is very stringent, very limited. Basically, only recycled plastics that comes from authorized recycling processes, which are authorized at the European level, can come into contact with food. And there is a regulation that pretty in more detail describes the authorization and the application of these authorized processes. And when we talk about plastics as waste, as I said, all these provisions are put forward in order to reduce the use of plastic packaging or the generation of plastic waste, actually, and to improve its treatment. And most importantly, the recycling of plastics. There are general provisions of waste that are also applicable to plastic packaging. It's the waste hierarchy, it's the polluter pays principle, which is the basis for the extended producer responsibility. There are certain waste management requirements. Most importantly, responsibilities in some cases are very clearly specified. So as we said, we have the requirement that the producers who place the packaging on the market are required to cover to organize the waste management of plastics or to cover the costs of the waste, the plastic packaging waste. There are also some permits, registries, and so on. What I would like to talk in a little bit more detail are the recycling targets. They are very important because they are the ones that will drive and motivate and urge the relevant entities to put more effort to increase the recycling of plastics. We have municipal waste recycling targets, and we also have packaging waste recycling targets and specifically plastic packaging waste recycling targets. Let's go first to the municipal waste recycling targets. Why are they important for the plastics? Well, they are important because municipal waste may contain substantial portions of plastic waste. And there are two main reasons for this. First, as I mentioned, plastics that is not plastic packaging is usually not sorted as plastic packaging. It is put into mixed waste. So it ends up as municipal waste, right? So this is one of the sources of plastics in the municipal waste. The other source is that unfortunately plastic packaging is often not properly sorted by consumers. Many consumers just dispose of it and put it into mixed waste. So that is another reason why we have a lot of plastics in the municipal waste. And that is the reason why these targets for municipal waste are also important for increased recycling of plastics. Municipalities will have to put more effort in order to separate plastics from the mixed waste and to further treat it and recycle it. The target for the reuse or recycling of municipal waste that is to be achieved by 2025 is set at 55%. And there are later targets so that by 2035, this recycling rate should be 65%. When it comes to plastic packaging, we have a specific target related to plastic packaging so that by the end of 2025, the recycling rate for plastic packaging should reach 50%. And by 2030, it should reach 55%. These numbers show you that the collection and the separate collection and recycling of plastic packaging has not been that efficient so far. So more effort is put into improving it. And I will mention just another point, and these are these calculation methodologies that I mentioned in the brackets. The European Commission put forward some new requirements and new methodologies for the calculation of recycling targets. And why are they important? Well, they are important because they put the calculation of the recycled content forward into the recycling process. So in the near future, for example, only plastics that entered the recycling process will be counted as recycled plastics. Until now, we had, for example, that plastics that entered the treatment, that was collected and entered the treatment, was counted as recycled, although it contained unrecyclable plastics, or it contained dirt, or maybe labels and so on. So there was some portion of material that was not recyclable and was not recycled as plastics and was calculated as recycled plastics. That will no longer be the case. I'm sorry if I took more time than envisaged. I'm at your disposal for any questions. Thank you.
Thank you, Alexandra, for your presentation. Now it's time to see if the audience has any question regarding your presentation. We saw that there was question for Hasso that we were not able to answer. But first, I would like to see if we have any question for Alexandra. Mara?
We still don't have any specific question. I don't know if Hasso is here to directly answer the previous question.
Yes, I'm definitely here. I can answer the question. Let me see.
Hello again. So the question was about research. Is there any ongoing research about managing biodegradable plastics in mechanical recycling facilities?
Okay, maybe we should maybe we should be aware of the fact that biodegradable plastics don't belong in mechanical recycling, period. That's why biodegradable plastics should be only used for applications where it makes sense. In most cases, it's applications that are liable to be contaminated with food, because these will not be recycled, period. That's why the idea of them ending up in mechanical recycling is something that should be avoided. But of course, you will not always be able to avoid that. So the sorting techniques that exist today can easily detect those from every other polymer as well. Again, to remind everyone, there are so many different kinds of polymers out in the market. If you are a recycler and if you are actively collecting a specific polymer, polyethylene, PET, or whatever, every other polymer is a potential contaminant. Biodegradable plastics are no different. They are not worse or better. They're just also a different polymer that needs to be sorted out in those facilities in order to have a good recycling quality. And that's why giving biodegradable plastics the impression that they are worse for mechanical recycling than any other polymer just is completely wrong. So it's not about trying to make biodegradable plastics recyclable in conventional or in mechanical recycling. It's trying to avoid them ending up there in the first place by limiting it to specific applications. And if they end up there, then you need to sort them out with all the other plastics, and then incineration in most cases is the best solution. I hope that answers the question.
Thank you, Hasso. Yes, I think that your answer was on point. So thank you for explaining us more things about the recycling facility and the difficulties we have around the recycling facilities. And so for Alexandra, the audience is thanking you for your presentation. It was very exhaustive. And we have a question for you, Alexandra. What is your opinion on the fact that the European Union doesn't consider microbially produced biopolymers not suitable for single-use applications?
Thank you everyone, and thank you for the question. Unfortunately, I'm perhaps not the most suited person to answer to this question. I'm an economist by profession, so perhaps someone who is more into this kind of technology. I can provide maybe an overview of policies, but would not be sure to provide opinion related to this. I'm sorry for. Maybe someone else could provide better answer to this.
And we have another question for you about your presentation. So I will read it. And Alexandra, you mentioned that to increase producer responsibility by 2025, producer will become responsible to organize the waste collection or cover the cost of cleaning up the waste. What will happen to producer who will not do that? What are the costs of this?
Well, the European, it is up to the member states to organize these activities, to impose the requirements. So the member states are required to impose the measures on the producers to attain these requirements, and also they are required to impose these penalties. So it's up to the member states. The European Union does not specify this type, because these areas of waste and food safety and everything is the shared competence between the European Union and the member states. Basically, European Union usually imposes some requirements which are obligatory for the member states, and it's up to the member states to decide how they will apply this in their own context. So there are no specific requirements at the EU level, but at the member states level.
Okay, thank you so much, Alexandra. And we have several other questions, but they are more based on the chemical part of bioplastics. So I will, Pablo, if you agree with this, I will leave this question for after the presentation of the project. So because I know that some of the project could answer question on PLA and the chemical degradation of plastic. So
yes,
Pablo,
I agree. In order to follow the timing of the agenda, most of the question I'm sure is going to get answered by the time that the project coordinators are showcasing their projects. But again, at the end of the workshop, we will also have a Q&A section, okay? And you also have the emails of the speakers in case you miss the answer of your question. But for now, I think we move to Cristiano now to introduce UPLIFT. Cristiano, the floor is yours.
Thank you, Pablo. I'll try. Just a second. Can you see the presentation now?
Yes, we can.
Okay, perfect. Thank you. So, good morning, everyone, and thank you for joining our joint workshop and webinar today. As you can see, my name is Cristiano, and I'm working at the Aalborg University, where my main focus area is on biorefinery processes, so trying to valorize different waste streams into higher value products. And I also have the pleasure to coordinate the UPLIFT project and consortium. So today I would like to introduce a bit our concepts and the participants. Yes, so UPLIFT, what is UPLIFT? It is a 4-year project. It's a collaborative effort that started in spring this year, and we would like to contribute to the development of a more sustainable plastic value chain in the drink and food packaging sector. So more concretely, UPLIFT wants to develop new biotechnologies to depolymerize large plastic streams that are currently not recycled or not recycled efficiently, at least. And we would like to upcycle them into more renewable polymers, which will have to be easier to recycle in the end. So an example of those large streams that are not efficiently recycled so far could be, for instance, the mixed plastic waste that was already mentioned by Hasso and Alexandra, but also think about multi-layers and also the these contaminated plastics from food packaging, for instance. So the overall idea of UPLIFT is somehow to change our way of thinking and using plastic. So going from a traditional linear way where we produce, reuse and throw out the plastic and consider it as a waste, to a more circular plastic sector where we would like to integrate already existing mechanical recycling, you developed chemical recycling, also with biochemical recycling. So the main take-home message here for us is basically to have a change from a linear way of thinking and using and producing plastic to a circular, more circular plastic sector. Okay, so to put things a little bit more in a context, we maybe should introduce first of all the topic, the Horizon 2020 Biotech 09 topic, which is these are research and innovation actions funded by the Horizon 2020, and we have so specific requirements from the call, and that the UPLIFT project was constructed in a way to trying as much as possible specifically address these scopes and expected impacts. And here you can see several ones. I will mention just a few of them that are most relevant. So starting with the design of bioplastics that are recyclable or biodegradable. And this technology should be based on biotechnology, so either enzyme or microbial degradation, for instance. The second point I would like to highlight is the need to develop standards and certification schemes. And the importance of this was already introduced by Alexandra. And then the third important point is maybe also to focus on social sciences and humanities, which is maybe a relatively new requirement for Horizon 2020 projects. And this hints maybe already at the fact that if we really want to overcome the plastic pollution and plastic waste problem, we cannot rely exclusively on technological solutions, but this probably involves also other stakeholders. So important also to keep in mind that we're asked or we're expected to contribute to reaching targets of 60% of upcycled packaging by 2030. And also that 60% of this plastic should be coming from renewable resources. So definitely a very challenging program, to put it mildly. If you remember, Hasso introduced already saying that currently bio-based plastics are less than 1% compared to the total worldwide production. So a little bit about our consortium. As you can imagine, if we want to tackle such a big challenge, we cannot really think that this can be solved by one single research group. And in fact, UPLIFT sees the collaboration of 15 different partners. You can see them here from 8 different countries. And the important characteristic here, I would say, is that we have a strong consortium that has strong complementarities, and we will work together to develop these new eco-polymers that should be easier to recycle, and we will need to demonstrate this at the pilot scale. So the structure of this consortium reflects a little bit our ambition to target the whole value chain, which means that in the partnership we include, for instance, a recycler company, such as the case as Vestforbrænding from Denmark. Then we have several research and development partners working on the biochemical recycling and upcycling. And you can see we have Forschungszentrum Jülich in Germany, the Austrian Center of Industrial Biotechnology, we have Lund University, Leibniz Institute, HKI, the University College of Dublin, and also Aalborg University, which will jointly work on different solutions that then will be compared with each other. And we of course also have the need to have the support of polymer chemists. So we have also the contribution of the DTU Polymer Center and the Technische Hochschule Aachen. and as well experts in economic environmental assessment, in this case the partner from DTU Environment. Partners, finally, I mentioned that we want to scale up, so we have of course also partners that are have a strong capacity and expertise in the scaling up process. So we have the European bio-based Europe pilot plant, we have AIM Plus and bioplastic, and last but not least we have producers of bioplastic such as Biomi and Tecnado, which in the end will test our new ecopolymers. And finally, of course, I cannot forget to mention the important support of Sustainable Innovation Europe, that is our dissemination exploitation manager, as Pablo already mentioned, and they are of course also were actively involved also in the organization of this joint workshop today, together with the dissemination managers also of UPET and PRESERVE. As you can see, to try to make sure that the UPLIFT solutions are also of industrial relevance and interest, we also have an external advisory board, and here we see a collaboration of some important international companies. We see Corbion, Novozymes, Tetra Pak, and also Pack for Food. So about a bit the general concept, in a simple, very simple synthetic way, we can see that our concept is to couple biotechnological depolymerization of plastic waste that nowadays is not properly recycled, together with the integration of renewable bio-based building blocks. So we would like to integrate, you can see here, we start with post-consumer mixed plastics, develop new biotechnological solutions to depolymerize it, and then instead of recycling it back, we would like to integrate it with more renewable and bio-based building blocks. And our ambition is then to scale up the process, identifying the best technologies that have the potential to be scaled up, and the idea is then to test them in a pilot scale up to 2,000, 3,000 liter reactors, and in this way reaching a final technological readiness level of 6 at the end of the project. So the expected impacts of the UPLIFT technology will then be to basically contribute to reaching these targets that the Biotech 09 call somehow required. So we would like to contribute to increase, of course, the contribution of bio-based or renewable plastics, and also to bridge this gap going from current 40 to 40% of recycled plastic in the packaging sector, at least, all the way up to the 60%. And how can we make sure actually the solutions that will be developed in UPLIFT are actually can have a potential impact on a large scale? And there might be maybe different strategies, but the solution that UPLIFT identified was to start with the analysis of the current plastic packaging demand. And you can see here, we started with the use and demand of different kinds of polymers in the packaging sector in Europe. And then we compared this with predictions for the coming years, coming, for instance, from Europe bioplastics. So the introduction from Hasse was actually exactly some of the forecasts that we took into consideration to identify those plastics and those bioplastics that will probably become more relevant in the next couple of years. And also then we also considered, of course, the technical substitution potential of these materials. So in this way, we managed to identify a target list of materials that we believe will have a relevant impact also in terms of large volumes. And that became then the focus of the UPLIFT project. And I will come back to these materials in a couple of minutes. So how will we then reach this challenging goal of 60% renewable plastics and 60% recycling, or how can we contribute reaching these goals? Well, as I mentioned, through a close collaboration, there is no one that can solve this problem alone. So through the integration of the different complementary expertises of the consortium, starting with the development of different biotechnologies for improved depolymerization of post-consumer plastics. So to obtain plastic hydrolysates and as much as possible pure monomers that we can use. And then we have the collaboration of different partners to work on fermentation of new building blocks and also bio-upcycling of some of the residual streams of the plastic hydrolysates that cannot be purified. So these monomers from the plastic hydrolysates and the building blocks will then be integrated and used for eco design. So try to combine them in a way that will make the future recycling easier under controlled conditions. And at this point, we basically decided to insert a sort of checkpoint. So before scaling up the technologies, we decided to make a comparison of all the different solutions that the partners will develop on a lab scale and compare them using techno-economical evaluations, life cycle analysis, so to assess the economic viability and the sustainability of the different processes. And the most promising ones will then be scaled up and then also these polymers will be used to produce plastic products that will be tested. And then after the scale up, we will be also, sorry, it's a bit delayed, test also for improved recyclability. Okay, so in this slide, we can see a short description of the different work packages, starting with the overall assessment of the value chain, and then continuing with the research and development part, and finally the assessment of the economic viability. And what I would like to point out here is that there is also that we also foresee an important information loop that is basically feeding back from the work package 5, so from the technical, economic, and sustainability assessment back to the R&D work packages, providing useful information on how we can improve the processes and make them more sustainable or more economically viable before going then for the scale up. So now, if we want to take a look at the material flow, so the type of plastic materials that we have identified and considered strategic, you can see we decided to start with 3 big categories, which are largely used. And you can see here, starting with multi-layer packaging, think about, for instance, Tetra Pak drinking packages made of different layers of different materials, not only plastic, there could be also different kinds of cardboard, paper composite, cellulose, there could be aluminum, and so on. So these are really, really challenging and almost impossible to recycle mechanically at this moment. And so maybe the biotechnological solution using enzymes that have a specific affinity for certain substrates might actually be a solution to depolymerize, without the need of sorting previously the materials. And then, of course, we want to consider polyesters, which are largely employed in packaging, and the biggest group then, of course, the different kinds of polyolefins. So if we want to follow the material flow, we start with this depolymerization of this waste. This should be mixed waste that is not properly recycled at the moment. And we want to obtain different monomers. Here you can see some listed, of course, from terephthalic acid, ethylene glycol, if we talk about the PET, for instance, but we'll also get probably different kinds of diols and different kinds of carboxylic acids as well, and different oligomers from the polyolefins. So in the fermentation and upscaling, you can see there will be quite a bit of diversity. Again, we will try to use organic substrates or organic waste, to produce, for instance, furan, carboxylic acid, caprolactone, different kinds of polyhydroxyalkanoates or butyrates and copolymers in different combinations. And finally, then combine these building blocks from the two previous steps and through eco-design then obtain different kinds of new bio-based and more carbon neutral ecopolymers. So trying to look a little bit more into the details of how we actually think to work with these different materials. You can see here we will start with this waste stream coming in, and we will try to disassemble it and obtain as much as possible these useful pure monomers. You can see, for instance, we can imagine PET could be hopefully very efficiently depolymerized into two building blocks, so into the two monomers, terephthalic acid and ethylene glycol. PBAT, for instance, we assume that we can separate the adipic acid, 1,4-butanediol, terephthalic acid, and so on. So this can be then integrated and coupled with the fermentation products. Imagine, for instance, that we use furan carboxylic acid, or we ferment, or we produce caprolactone or lactic acid that then can be converted in lactite and so on. And through a specific combination, we could actually then use, for instance, I don't know, the fossil-based terephthalic acid from PET together with fermented, for instance, furan carboxylic acid, and we could produce PEF, for instance. Another approach will be we can use the monomers like terephthalic acid or also ethylene glycol with engineered strains that can then convert them directly into PHA, for instance. And here you can see different other examples. Sorry. Yes. So to prove, finally coming to the end of this presentation, to prove that our new eco plastics actually are easier to recycle, we will then produce different types of materials, for instance, flexible films, rigid trays, plastic bottles, in order to prove actually their properties, their hopefully improved properties, and also their improved recyclability. So you can see here our ecopolymers. We need to scale them up in order to reach technological readiness level 6, obtain the products, test that they actually have good functionalities, and then they will be fed back to our depolymerization work package, which is work package 2, and we will test actually that they can be easier recycled than the incoming waste stream that we had at the beginning. So here the take-home message is that to obtain a more sustainable plastic industry and contribute to the circular economy, we need to make sure that plastic is not considered as a waste anymore, but as a resource, and we need to keep the material in the loop. And this is, I think also, this goes definitely in the hand in hand with what was already presented by Hasso. So finally, I would also like to thank everyone for listening, the audience, of course, and also just say that, of course, I'm not doing all this alone. Apart from all the consortium, I also have a strong support from the Aalborg University team, both from an administrative management point of view and also from a scientific point of view. You can see here some of the main colleagues that support and help, both in the, for instance, in the molecular biology part, protein engineering, and the study of social sciences, and also finally, to conclude last, I would like to thank the audience for participating and for listening to this presentation. Thank you.
Thank you, Cristiano. And I will now take the floor because we have some questions for you.
Okay.
Okay, so the first one is about which partner is providing enzymes for depolymerization.
Yes. Basically, if you remember, I showed a slide where we saw different partners involved in a work package 2, which is this depolymerization of the different mixed plastic fractions, meaning that each partner will involved in the R&D will develop their own biotechnological process, developing their own enzymes or wholesale systems. So for instance, Aalborg University will try to work with PTases and then try to improve thermostability and activity. ASIP will do the same with, for instance, with thermophilic hydrolases, for instance. In the case of University College of Dublin, they have engineered Pseudomonas strains that can upcycle directly terephthalic acid, for instance, into PHA. So each partner is developing their own biocatalysts, if you want to call it that way. And then the best solution will then be transferred. There will be a technology transfer. And Leipzig Institute HKI will probably scale up the production of the enzymes in a larger scale.
Mara, you're mute.
Sorry, we have another one, thank you. What kind of formulation you will apply to polyethylene furanate to be used as ecoplastics for food and drink packaging, as depicted in the slide of the project overall concept?
The formulation, so this is something that will be developed basically. So the partners from the DTU Polymer Center, who are world package leaders and will develop all this eco design with different kinds of monomers and building blocks coming in. So there is not a solution yet. So we don't have the exact answer for PEF, exactly what will be the solution. We know, of course, one of the reasons why we targeted PEF is that we already know that it is easier to recycle compared to PET, and it has improved barrier properties compared to PET, so it is already upcycling. But the exact chemical eco-design as a solution that DTU will apply, I personally, I don't know it yet, and I don't think yet that DTU knows it, because it will depend on the purity of the monomers that we receive. And then also, of course, techno-economical evaluation, the property of the materials. So this is something that will be developed, and I don't have the answer yet for the different monomers and products.
Thank you so much. And then we have other question about the purification and the purity. The first one is, how do you purify the mixture of different monomers resulting from depolymerization of mixed plastic waste? And do you face problems with contaminants?
Yes, this is probably one of the biggest challenges, and I know that this is a big challenge across all projects that work with recycling of plastic, also with chemical recycling. And there are, of course, there's a partner that will take the lead in trying and comparing different kinds of strategies, depending, of course, on the composition of the mixtures. So we'll try from, I don't know, crystallization to chromatography. So we'll try different kinds of strategies, and also depending on the purity that we need to obtain. This is something that I think will probably be one of the biggest challenges, because the partners from the Polymer Center, they would like to have as pure monomers as possible. But the reality is that when you have such complex mixtures, you will not really be able to do that in an economic viable way. So we will need to develop systems that can work with a bit more dirty mixtures and maybe not completely depolymerized polymers. Think about the polyolefins. We will not obtain monomers of polyolefins. We will obtain different oligomers of different chain lengths, and we will be we need to develop then a repolymerization strategy that is able to cope with that. So also in this case, we will compare different kinds of downstream processing that are available in literature based on the expertise and experience of the partners. But again, we don't know which will be used, and it will change also depending on the type of mixture that we will receive. So we actually, this is one of the big challenges of UPLIFT. We need to keep it flexible because we want to test different kinds of plastic types coming in, meaning there is a huge diversity. So we don't have one exact strategy that we know this is what we will scale up, but we'll test different ones, and the best one will then be scaled up.
Okay, thank you for your answer. And we have another one. Most of the reported enzymes mainly attack on the amorphous region of PLA. What should we need to target the crystalline part of the PLA?
Yeah, I think this is the big, or maybe the biggest challenge when we work with enzymes and try to use enzymes to depolymerize any kind of polymer, also natural polymers. I mean, we've seen the same issues also with lignocellulosic biomass. So one of the strategies that are used right now and that are the most winning strategies are basically to use, in the case, imagine for instance PET now, and I assume that it will be the same with PLA. If you can develop thermophilic enzymes that can operate at a temperature that is very close to the glass transition temperature of the material. So that's what Carbios has done, right? French company that has now scaled up and has just started the demonstration scale of the process, and they're able to depolymerize PET with enzymes within 10 hours, basically. So really enzymatic depolymerization of industrial relevance. They were doing it with PET bottles. And the strategy was exactly to engineer enzymes that are more thermostable, that can operate to temperatures 65, 68 degrees. So getting very close to the glass transition of PET in water solution, meaning that the crystallinity of the polymer decreases significantly, and then you can have an efficient depolymerization. This is the strategy that we know works. There might be other ones trying to work with enzymes that can tackle maybe also more crystalline ones, but this is not something we know yet.
Okay, thank you so much, Cristiano, for your answers. And Pablo, I will leave the floor to you.
Yes, thank you so much also, Cristiano, for your presentation. And now, according to the agenda, we will have a 10 minutes break. So what about if we come back at, let me share my screen. From 12:30 to 12:40, okay? We will be back with the next project presentation, which is gonna be PRESERVE. The next presentation is PRESERVE. The project is gonna be introduced by Aldo. So Aldo, the floor is yours.
Okay, thank you, Pablo. I will share my screen. Okay, do you see the entire screen, the presentation mode?
Yes, we can.
Okay, thank you. Well, first of all, I would like to introduce the project itself. It's called PRESERVE, which stands for, as you can see here, high performance sustainable bio-based packaging with tailored end of life and upcycled secondary use. My name is Aldo, and I work for Iris. We are a small SME located in Barcelona, and I am only here the speaker of this amazing team that we are in PRESERVE. In the main figures, well, PRESERVE is an European funded project under the Horizon 2020 program and under the topic Upcycling Bioplastics for Food and Drinks Packaging. This is a 4 years duration project, and we count with 26 partners inside of the consortium. Between them, we count with 7 research organizations and several partners along the circular value chain from the producers until the end users. And trying, as similar as Christian said before, trying to reach and to explore and to validate a circular route instead of the linear classic one that we have in the current industrial processes. You can see on the right a value chain scheme of the partners we have inside of the project in every single area that we divided. And well, on the left, you can see a schematic representation of where they are placed in Europe. Well, The next question would be why PRESERVE is needed. Why do we need such an action on the problems that we have to tackle? Well, here we just summarize 4 single bullet points on reasons why we think PRESERVE is needed. The first one will be that Europe consumes more than 50 tons a year of fossil-derived plastics, meaning that they are brand new produced, 40% of which are only for packaging, food and drinks packaging. This will be, well, it has already been mentioned before by Alexandra that not all the plastics that we produce are counted for packaging, meaning that this number can vary. But we believe if it varies, it will be for an excess of plastics being used for packaging. The second one will be probably the most important one on the slide, which is the only 42 or approximately 42% of the plastic waste is currently recycled, meaning that all the rest is leaked either to the environment or is damaging or is being accumulated somewhere. The third one would be globally, over 30% of the plastic is, well, as I just mentioned, leaked to the environment, and this leads to everyone knows it, to a dramatic long-term pollution, which is having consequences right now. And the fourth one will be that the bioplastics have advantages in terms of renewable feedstocks, as commented before by the previous speakers, and the modularity they have will represent a very limited share of the plastics, calculated between 1% and 2%. So from these points, together with the European targets in terms of CO2 print food neutrality by 2050 and circularity by 2030, we believe we have to sort this situation out. I will not say to revert it, but at least to help not to damage a lot. How PRESERVE could help on that? Well, we believe in high-performance bio-based materials need to be developed and produced, and to be produced for being used in recycling approaches that need to be very well established and need to be in motion. Altogether with that, biodegradability of polymers that we have already been used in applications can be expanded and have to be excelled to other environments and industrial environments mainly. So as a brief description of the objectives and how it is handled in PRESERVE, we have here a schematic representation in which I will try to explain not too in technical details, but to have an overview how we approach this. At the beginning, we have new polymer synthesis, mostly based on fossil sources. These polymer synthesis go to packaging or can go to one of the PRESERVE blocks of activities that we have, which is the upgrading of these biopolymers. From this upgrading, we can produce textiles and composites, or we can produce packagings. But this step is very important. From these textiles and composites, they are being used after a first life, and then we have the end of the life of these products. In here, we have also 2 blocks that we are tackling in PRESERVE. The first one will be the material recovery, in which we have different kind of technologies and techniques such as delamination and other reinforcement, from which we can produce new recycled biopolymers that will go back to the value chain as bioplastic to be upgraded and to form new textiles and composites. On the other hand, after this end of life, we have 2 other possibilities. The first one that we are deeply working on it is the enzymatic recyclability of these products, from which we will obtain oligomers. These oligomers can be introduced to the new biopolymer synthesis instead of the fossil sources that we have already. The second one will be the biodegradation of these products, in which we'll produce biomass, and this biomass, after certain treatment, could be also integrated again into the value chain. In order to perform this cycle and to have all these technical details in place, we use different technologies and techniques such as protein-based coatings for additives, treatments with different biopolymers with e-beams. We use also a reinforcement of the biocomponents in order to be used for packagings, mostly for food and drinks, but we also target other markets and other industries such as the personal care and the transport of packaging. In here, we can also see a figure on how these technologies and techniques fit into the circular view of the project for finally ending up in the demonstrations that we have. Well, this slide is just to show what are the main demonstrators that we have in the project, and I would like to emphasize here the visual value of this image, because if we focus on the left side, we see snack packs, films, trays, beverage packaging, and we should be aware that all these products are present in our everyday life. We are all used to go to the fridge to get a pack of cheese, a pack of meat, use it, and then dump the trays or the lids. So this is a real problem, and here is where PRESERVE and, of course, our fellow projects that will be explained during the session have a mission, have an objective. Well, this last slide is just to show how the project is organized inside. As you can see, we have 4 different pillars, which are the technical work packages of the project. The first 2 at the top in green are the development and the tailoring of the packagings. I mean, when I explained before that there is one block that we do the combination of different techniques for the enhancement of these materials, here in work package 3 we have the basics and the study of it, all the validations at the lab scale, and then in work package 4 we pass to the upscaling of those materials and new blends. Similarly, on the blue blocks, work package 5 and work package 6, we have them devoted to the recycling and the biodegradation processes of the end-of-life materials. In here, in work package 5, we do it again at the lab scale and the specifications, all the research involved. And then in work package 6, we have the upscaling and the validation of those new packaging products and the textiles. Well, these 4 blocks are surrounded, let's say, by 3 more work packages. This work package 2 is in charge of the definition and the specifications in terms of entities, in terms of regulations, and in terms of standards, and is gluing the entire activity of the technical work packages. On the other hand, we have safety and environmental, well, the usual assessments that we have in order to keep all the track of the activity of and the results of the technical work packages. And finally, we have the work package 8, which is in charge of the roadmap and the innovation and impacts of all the results and all the activity we have. All these work packages, again, are glued by the management, which I have the pleasure to serve for. But I have to say that it's merely a monitoring of the project. I mean, the whole consortium is the one doing the job, and so far we have a magnific activity performance. Finally, well, it was a brief presentation. I didn't want to get too technical into the description of the project. If you want to know more about it, well, here are the main contacts, and I will be very happy to answer questions that you may have.
Thank you so much, Aldo. Mara, I don't know if we have any question regarding Aldo's presentation.
We still don't have any question, but feel free, as always, to ask anything you would like to know about PRESERVE, about the technical details. Of course, here we are. I am in charge of the communication together with Christian Schultz from European Bioplastic of PRESERVE, and I wanted to underline what Aldo said, that it is a pleasure to work in such big projects and with such important objectives. So we are really pleasure to be involved in these activities. And Pablo, I don't know if you want to go on with the other presentation so we can move on. I think it's Fuensanta,
yes,
the next speaker.
Correct. If you have any other question for Aldo further, we can answer them in the at the end of Fuensanta's presentation. Fuensanta, the floor is yours.
Hello,
Welcome.
everyone. I'm gonna share my presentation first. Okay.
We can see
thank you. Can you see it?
Yes, we can.
Okay. Thank you. Thank you, Pablo. And to all of you, to all the people attending this workshop. We really have enjoyed this collaboration with our sister projects. And we are very glad to present at PET, in which we work and are working very hard. So we are very proud of this work. Well, the idea of a PET project, upcycling of PE and PET food and drink packaging waste, came up at CETEC, the Technological Center of Plastic in the region of Murcia in Spain, and was CETEC who prepared the proposal with the help of the rest of the consortium. CETEC has been working on plastic research for more than 20 years and has participated in several European projects, either preparing the proposal or as coordinator, as well as being part of the technical teams in the different tasks and work packages. Sorry, because I can't move the slide. I don't know why.
Try with the right or down arrow in your keyboard.
No,
okay.
That's all right. Okay, thank you. Well, Cristiano already talked about the program and the topic of this project. The three projects are fellow project, so I'm not going to go into it, but I'm going first to talk about the project figures. This project has a contribution by the European Union of 7.8 million euros. It is a 4-year project. It started in November 2020 and will end in October 2024. The consortium is made of 20 partners. You can see here the logos of the partners, but you can find more detailed information in our website, upet.eu website. And these partners come from 2 different countries, Italy, Spain, Germany, Serbia, Austria, Finland, Estonia, Greece, Turkey, and Croatia. Well, the consortium was prepared trying to include all the value chain. It is a multi-sectorial and multidisciplinary approach in the consortium. And on these charts, you can see the level of representation of every actor and sectors. Among our partners, you can find industry for the validation of the product, universities and research institutes that are experts in all the technology that we are developing, also standardization and consumer organizations. And the industries involved in the project are biotechnology and bioplastic industries, plastic compounding and processing industry, and also food industry from food industry and drink industry. Here you can see a diagram that showed a PET ecosystem which follows the circular economy criteria. First of all, we are collecting the PE and PET packaging, and we are enzymatically treated, recycling this waste. And then the resulting product will be used to produce in bioprocesses, in 3 different bioprocesses. They are going to be used to produce a biodegradable material. This biodegradable plastic will be of the kind of polyhydroxyalkanoate range. Then this polyhydroxyalkanoate will be compounded to obtain the suitable material to be able to produce and transform this material into food packaging. Then this food packaging will be used again by retailers and by consumers. And this new packaging will be able to be recycled again and to enter again in the value chains. So this in a way of closing the cycle. Now I'm going to describe the different technologies associated to the PET solution. The starting point is the PET and the PE packaging waste. You can see here in these images some of the waste we are going to treat and we are treating: drink-packed packaging, high-density polyethylene caps, low-density polyethylene films. Also, we are going to treat PET trays, high-density polyethylene blown bottles, wrapping films, and even multi-layers. In a first step, P and PET packaging will be sorted by colors, by origin, by type, and then will be pre-treated in order to improve their affinity to the enzymes, to make it easier for the enzymes to attack the plastic. After these pre-treatments, the enzymatic degradation processes will take place through a customized biocatalysis. It is important, this customization, because it aims to optimize the performance of the enzymes and the yield of the process. The resulting product will be the monomers of PET, terephthalate acid and ethylene glycol, and short-chain alkanes from the polyethylene waste. It is important, one of the important parts of the development is the upscaling at semi-industrial level to reach tier L6. Moving on to the second stage, and from the starting product resulting for the first stage, that are the N-alkanes and the TPA. These two products will be go to two different bioprocesses. N-alkanes will be used in a bioprocess to obtain fatty acids rich biomass, and the TPA will be used in a bioprocess to obtain protein rich biomass, both through the corresponding bioprocess based on microorganisms that are able to metabolize the products. Then these two resulting products, the fatty acid rich biomass and the protein rich biomass, will be used together with a sugar-rich food industry waste that comes from one of our partners in a biotechnological production of PHBV. In this cell factory, we are producing polyhydroxyalkanoates of the type of PHBV. Then the other resulting monomer from the enzymatic recycling of PET will be used as a green solvent in a green extraction process. And thanks to this green extraction process, we will be able to get the PHBV from the cell, from the biomass. Another important activity of this part of the project is using different feed strategies in the PHVV cell factory. We are modulating, thanks to these different feed strategies, we are modulating the composition of the resulting PHA as a result, its properties. As in the previous stage, it is important the upscaling, the pilot scale of these processes to get at the end of the project a TRL 6 level. Now, in a third stage, the PHVV obtained in the cell factory will be compounded in a compounding extruder in order to obtain a material with other ingredients, but assuring that it will be biodegradable. And we are going to obtain different grades of biodegradable plastic with the required melting behavior and properties to be used for the manufacturing of different type of packaging. This activity aims to produce these different grades of biodegradable plastic in order to have a semi-industrial scale of the product and be able to further perform an industrial validation. Moving on to the final stage of UPET solution, the technical part of UPET solution, the different grades developed in the previous stage will be transformed into flexible, rigid, and semi-rigid packaging using standard processing plastic technologies such as injection molding, film extrusion, or thermoforming, all in order to obtain packaging for the validation of the packaging performance by the end users in an industrial environment. The packaging will be validated in lollipops, sticks and envelopes, biscuits, bags, and meat films and trays. And now I'm going to describe important cross-cutting activities that have been included in the project for a systemic approach. The objective of UPET project is not only the development of an innovative solution for food and drink packaging upcycling, but also to make sure that the solution is environmentally friendly and beneficial for the society in general. Even we can use this project to improve the behavior of citizens and related industries in regard to food purchasing, waste recycling, and gender aspects. As Alexandra said before, an important part of the European policies is being able to manage the municipal waste. So the citizen behavior is an important part of this municipal management of waste. And as part for the evaluation of the environmental impact of a PET solution, we are carrying out a life cycle assessment, social life cycle assessment, and life cost cycle. We are also going to valorize all byproducts to include them in the value chains because we want a PET solution to be a solution zero waste. And finally, we are performing the necessary studies of recyclability, compostability, and biodegradability in the different environments to assure that the UPET solution, UPET packaging, will be properly managed when they become a waste. And another important part of the project is activities that have to do with the integration of social humanity and gender aspect across UPET. We are going to study the current attitude of European citizens with respect to recycling and purchasing food and drink packaging, including gender perspective, to design a roadmap that aims to improve consumer behavior and attitude. Besides, UPET is going to study the gender structure in the recycling industry and propose measures to the industry for the gender equality. Other important cross-cutting activities will be the contribution of UPET to standardization and certification within UPET solution field, to propose new methodology that seem necessary to the development of the project or that result from the project works. The elaboration of exploitation, innovation and business plans to assure that a solution will be in the market in the near future with the proper rights for every partner. Dissemination and communication activities to make a PET project solution be known by stakeholders, policymakers, decision makers, and the European citizens in general, trying to reach as mass audience as possible. And what is very important, the involvement of stakeholders, facilitating their contribution to the project with their knowledge, with their expertise, trying to reach as much actors and sectors as possible. And another important activity regarding with citizen awareness. Within UPET, we are enabling different tools for European citizen awareness, such as an European citizen platform and virtual reality based on mobile app, a massive open online course, and different awareness events such as workshops at educational institutions, visit to public waste recycling plants, and so on. Here, for example, you can see an image of one of the presentations we made about UPET in secondary schools in Murcia in the Science Week event. And the last but not the least, UPET will perform a deep review of the policies and regulatory frameworks within the European Union. You already know that Alexandra and their colleagues are responsible for this activity. And this tool is very important. This study of the European policies, it's very important because we can be aware of any change or new policy that come up regarding UPET processes and products. And we can then prepare and adjust our solution to these new policies. And even we want to propose measures and to suggest actions and new parts in the policies that currently the European Union is developing to improve the current legal regulatory framework in the field that had to do with UPET. And if you want to find more information about the project, you can consult our website and also our account in social media. And thank you to all of you for your attention. And if you want to ask me something, I am at your disposal for any question.
Thank you, Fuensanta. Mara, do we have any questions for Fuensanta's presentation?
Yes, we have a question, and
Yes.
it's quite a technical one. How do you convert PTA into a protein-rich biomass?
Well, this is a part of the innovation of our project. And I only can say that it is a kind of microorganisms that are able to transform this product into this kind of biomass. But I can't tell you what kind of a microorganism, because this is part of the confidentiality of the project, the technical confidentiality of the project.
Okay, thank you so much, Santa. And we have a question for Aldo from PRESERVE as well. How about the challenges of PRESERVE and how is going to PRESERVE face them?
Yes, well, as for challenges, as all projects have and all enterprises have, we have some technical ones, which are probably the hardest ones to tackle. Most especially because in PRESERVE we are quite ambitious and we have very, very ambitious technical goals, and we have only, I will say only, 48 months to cover an entire roadmap, which is challenging itself. But mostly I would emphasize the resource management and of course the risk monitoring of the entire project is probably the challenge itself. And but so far we have no signs of being unsuccessful on those challenges. One thing that I would like to highlight is the development of the entire route and the activities that we have, and especially the applications of those new products that we will develop related to the safety of the foods and the drinks that we are going to apply our new technologies. This will be probably the main challenge and probably one of the most important outcomes that PRESERVE will have.
Okay, thank you, Aldo. We have other question. I think it's for Fuensanta. Actually, they are quite similar and quite technical as well. What kind of pre-treatment you perform before the enzymatic depolymerization?
Well, as you all know, the enzymes work better with the plastic if they have certain characteristics like polarity, like low crystallinity. So our pretreatment are, the objective of our pretreatment are trying to get the plastic with the best affinity to these enzymes to make it easy for the enzymes to attack the plastic. So the pretreatment are aimed to get this quality in the plastic for the enzymatic recycling process.
Okay, thank you. And also there is another one. In what technological readiness level would you classify your research?
Technological, at the beginning of the end.
Maybe
well,
both. So
we consider a biotechnological research because there are many biotechnology processes involved in the project, and we aim to get a TRL6 in every stage of the project, in order to be prepared for the industrial implementation of the processes.
Okay, thank you, Fuensanta. And then there is another question that I think that Cristiano wanted to answer, is one from his presentation. From which suppliers you bought FD-SAB acid? Is it right, Cristiano?
Yes, so we have a partner, which is Lund University, that has a research going on to produce in-house furandic carboxylic acid. They tested different procedures, both chemical and chemical coupled with fermentation. So they will be probably providing the furandic carboxylic acid. And if we need larger amounts and we should not be able to provide them during the project, then I know that there are some industrial partners in Sweden that can actually provide it. So if you need a exact industrial contact, then I would say you would have to ask the Lund University, because I don't know the industrial partner, because it's only our contingency plan, it's our plan B. So our plan is to produce it in-house.
Okay, thank you so much. And I don't know, Pablo, if you want to start with the breakout session yet, because there is another question, but maybe this will be answered later on because we have another general question on the circular economy process in general. And I think that this will be also addressed in the last part of this workshop. So
yes,
Pablo?
okay. Okay, so let's conduct our Mentimeter activity. So before sharing my screen, I just want to make sure that everybody knows how this tool works. So let me share one slide for you. Give me just a second.
Yes, Pablo, I'm sorry for interrupting you again. There is another question, but I think this other question will be great also for the last part of the workshop, which is about the synergy between upcycling processes that are being developed and for which kind of packaging uses will those upcycling processes be most recommended. So if you agree, I will just note down and ask them later in the last part.
Okay. So here I think you can see the full screen. If not, it's okay. You just need to grab your phone. You just need to go through the website link that appears here, www.menti.com. And then you need to enter this number, which I can also, or Mari, if you can help me to type this number in the chat. So it's 98142929.
Okay, Pablo, I'm sorry. If you can switch the visualization because we can. Thank you.
Now?
Yes, now we can see it. So it's 98142929. So if you go to 3wmenti.com and you enter that code, you will directly participate to our breakout session.
Okay, I will move now to the Mentimeter presentation. So give me just a second. Okay, so let's wait a few more minutes. Mara, can you hear me good with the background music? Okay.
Yes, I can. Thank you.
Okay, there is a lot of people joining, so let's wait a few more. We have 33 and more people are still joining. If you have any questions regarding the tool, you can let us know in the chat. Okay, I think we can conduct our first question. It's gonna be like you get points if you answer the first one and it's the correct answer, okay? So I think you can join in if everybody is encountering any issue when joining, you can do it later also, okay? And you will see the question in the screen. For the first question is, what's the meaning of uplift? So in your mobile, you will see the different type of answers. Okay. Okay, quite good, quite good. Most of you has answered correctly, very good. Next question. is how much plastic produced worldwide every year? Okay, even with this tricky question with the numbers, most of you were okay. So congratulations. Let's see our next question. What is the percentage of bioplastic currently produced? Okay, very good. Most of you are keeping an eye on the work, so that's very nice to see. Let's see, our question number 4 is, how many percentages of the packaging is currently used in the market solution could be replaced with preserved solutions?
Hurry up.
Okay, most of you was correct. Next question is, oops, I think. How will polylactic acid be used in preserve? Okay, again, most of you was correct. I think the victory is gonna be very, very challenging between some of you. Question number 6. How many partners and countries are involved in UPET project? Okay, and again, most of you was corrected. Question number 7. What plastic weight are upgraded in UPET solution? Okay, congratulations one more time. I think we still have 3 more questions. Number 8. Number 8 says, what plastic is produced in UPET solution? I think this one is already answered, right? Oh no, okay, sorry. Okay, again, most of you were correct. Okay, this is one of the last questions. And it says, how UPET assesses the environmental impact of its solution? Okay, half and half. All the answer was corrected. And this is the last question. Let's see who is the winner after this question. And it says, which final products will use UPET materials? Okay, good job. Let's see if I'm not wrong. Now we will see who is the winner of this activity. Okay, so Estin Yelisius, congratulations, you are the the winner of this activity. So congratulations, and also the rest of the people who is in the first places.
Well, we hope you enjoyed this breakout session just to wake up us after all this information that we received about the project. Thank you.
Okay. Yeah, thank you, Mara. Thank you so much. I hope you enjoyed this interactive activity, but we don't want to finish the workshop with this activity because we have an open discussion now, which is regarding the importance of clustering, or why are we clustering 3 different projects here? And this is a very nice point to end this session. First place from my side, I'm truly glad to collaborate with UPET and PRESERVE, as well as the different partners involved in the organization of this workshop. I'm very happy to see that we had more than 100 of attendees today. So that's a very impressive number for us. So thank you so much. Additionally, I would like to let you know that this webinar has been recording, and we will share the recording with you to your email, and also we will post it on our social media channels. So make sure you keep tuned on our website and social media channels in order to not to lose the recording of the webinar. Mara, I would like to also thank you for being next to me moderating. But I would like to give the floors to you to spread out some of the dissemination or numbers that we recently achieved with this amazing collaboration.
Yeah, thank you. So for this event, we had more than 200 people registered. So half of the people actually attended the workshop. That is quite an impressive percentage for such events online. And so I wanted to remember also that European projects are on social media. So I would just invite you to follow all the 3 projects, PRESERVE, UPLIFT, and UPET, to be aware of all the events and communication activities that are going to be released in the next month, because the 3 projects actually just started, let's say, are they in their first year of activity, so more has to come. And so you will be able to see almost live all the results that they are going to achieve. And so thank you, Pablo, for organizing this workshop. And also I'm really looking forward to listening to all the ideas that we have about the importance of clustering, because it is important that European projects don't work only by themselves and leave the results inside their networks. And it is important. The importance of clustering, in my opinion, is also this one about collaborating and spreading the importance of researching activities outside the usual networks, let's say, because we need to have an impact on all the general public and stakeholders interested, because we have such important objectives, such as is reducing the waste that is going to pollute our lands in the near future. Thank you.
Thank you, Mara. Okay, so let me start the screen. The speakers can have the camera on. As you know, this is an open discussion. I think you can see the full screen, right?
Yes, we can.
Okay, so basically, I'm going to ask a question, and I would like to know from the different project coordinators your opinion about this point. In the first place, I would like to give the floors to Alexandra, okay, who is, I think she wanted to ask about the plastic policies framework. So Alexandra, if you are here, the floor is yours. So you may want to ask them any questions regarding plastic policies.
I was intending to raise a question related to possible modes of collaboration related to not only the plastic policy analysis and review, but also other social science and humanities dimensions. If I would be glad to hear from other coordinators about the activities that are going to be undertaken in that regard, and maybe to have them not now but in the future discuss possibilities for collaboration. In that regard, I would just shortly say what the SSH dimension within the UPET project involves. We are preparing case studies on the countries with high, average, and low recycling rates in order to prepare a comparative review of policies that are enacted at the national level to see which policies are more effective in stimulating the recycling and the proper sorting of plastic packaging. An important part of this would be the research on consumer attitudes and behaviors. While the previous part would be desk research, this will be a true field research. And I think these results and findings that we will obtain from this consumer research may be relevant for other projects as well. I don't know. We will also assess gender dimension. We will try to assess gender dimension related not only to recycling industry, but also to waste management in general, whether there are some gender aspects that could be relevant in order to increase the recycling and promote the recycling within households. And we will also tackle the possible distributional effects, because this can be also important for the proper design of policies. Well, that is in short what is going to be done within the UPET projects. I would like to hear more about other projects and also ask them to think and discuss possibilities for collaboration. Thank you.
Thank you, Alexandra. So maybe shall we start with you, Cristiano?
Yes, thank you. There's no doubt that we will need to work together, I think, also to have a bit of bigger impact also with policies. And I can tell you, maybe first starting with the policies and then going to the SSH part, to give an idea how important these policies are and how the EU projects should contribute maybe to reaching best practices. I can tell you a case study from Denmark. One of our partners is Vestforbrænding, that is the biggest recycler in Denmark. And a couple of years ago, they had actually quite some challenges because they were having an agreement with the Copenhagen commune to recycle 70% of the plastic sorted from the household waste. But they had a collaboration with Germany where they had larger facilities. So they were basically collecting the material in Copenhagen, in Denmark, and then shipping a large fraction of this out of the country. And based on what was sorted, there was an agreement that this was reaching 70%. Because the German factory was showing that they were actually collecting and sorting this amount of plastic. But what happened actually with this plastic was not documented. So the next step, was this plastic really recycled? Was there a tracing of the material? This was completely missing. So there was like 40% for which we had no track. And this was also due to the fact that according to the policy, it was enough just to say, okay, we are sorting out this 70%, so we're recycling 70%. And of course, this is the first step, but it's not enough because we can imagine that we sort it out and then we just put it for incineration, which is elegantly called some kind of energetic valorization, right? But this is definitely not keeping the material in the loop. So I think it's quite important that the policy gets a bit more precise and sharper in this aspect. So going to the social science and humanities study, what we are doing in UPLIFT, we've started again with a case study in the Copenhagen area because we know all the stakeholders involved. And we assume that, well, if we want to cover the whole value chain and we want to make it more sustainable, we need to have a dialogue with the most important stakeholders. So we started with the dialogue with the recyclers. We talked with the NGOs and plastic consumer associations. We talked with the municipality as a policymaker institution. And we talked with the Danish industry, so the plastic industry. And what turned out was that actually there was kind of a lack of dialogue between all these entities. And it's clear that none of these alone can solve the problem of the plastic solution and the, I would say, mismanagement of the plastic waste. So what we will try to do is to identify the causes and the reasons why there is a lack of communication between these actors. We were mapping the kind of contacts and communications, and we're trying to quantify in a, let's say, semi-quantitative way to visualize which different stakeholders had more communication and exchange and where it was lacking, and trying then to identify why it is lacking and what can we do as an EU project to support, to complement and to strengthen this communication. So this is the starting point where we are working right now with this SSH in UPLIFT.
Okay, thank you, Cristiano. Should we move with Fuensanta regarding this point?
Well, regarding this point, I think that Alexandra have said everything about UPET work in humanity, social humanity and policies. I would like to bring up another area of collaboration that is standardization and certification activities. We are all working on similar materials, on sometimes on similar processes. So I think this is an important area of collaboration, because we can develop a roving test to compare results when characterizing the polymers, when even when monitoring some bioprocesses, because even though they are different bioprocesses, they need similar control of parameters, so we can share experiences in this sense. So I think that in this part we can deeply collaborate, and even our partner responsible for standardization is UNE, the Spanish organization of standardization, and they are willing to collaborate with the partner of your project that are in charge of this activity. Even producing in collaboration the same workshop agreements. It is a kind of a standardization that is previous to the standards, the real standards. I don't know much about it, but that's what UNE explained me. So here we have a field of collaboration between the three projects. So.
Okay, so what about maybe Aldo could tell us a little bit more about what are they doing regarding in terms of standardization?
Yes, well, first of all, I would just like to start by sharing and joining my comments to Cristiano Sanfuensanta regarding the collaboration. This is a magnificent initiative. I do believe in the team work. So, well, I do. All the PRESERVE team, we believe in joining forces to do this, because none of us can do it alone. This is something very important, because we need to show not only technical solutions for this, but we need to show people, we need to show society that they are not alone neither, and we are developing tools and developing capabilities for tackling this problem. So I think it's a magnificent initiative in that sense. Well, regarding, I will just comment on the human impact and the results and the details that we can see from people getting involved. I will just mention one clear example, which is the amount of attendees that we had today. This is a very clear sign of people trying to get involved in this sort of activities and regarding this specific problem. I think it's very good that people get involved in this, and this is something that we monitor as well in PRESERVE in different kind of activities, how the people react to the information we give, and not to the results of the project yet, because it's kind of early, but all the different initiatives that we have inside the project. And finally, regarding standardization, I think this is a very, very difficult matter in terms of, well, as me, the people, we are not experts on that. So that's how I would like just to briefly give the floor to Christian and Mara, because they are working in PRESERVE and they have done an excellent job doing the assessment on that. So if Mara and Christian, you want to comment on this, please feel free.
Okay, thank you, Aldo. Christian, if you agree, I will just start by mentioning some points on the social science humanity part. So in PRESERVE, we have a dedicated task that we last for the 4 years duration of the project. And this is because based on the preliminary literal research that was made by our partner ASU, which is a university, based on the consumer acceptance and application of bioplastics, they realized that there was kind of perception problem, not on the primary material, let's say, but on the secondary raw materials, that is the part that PRESERVE is more engaged on. And also because we are going to use secondary raw materials for personal care and transport packaging. So something that people generally use more than, for example, a bottle of dishwasher, let's say. And it's more keen on using something that can be more bio-based. So we are focusing our attention on this secondary raw materials and also on the purchase intention, because also based on the preliminary literal research, we discovered that nowadays women are more keen on purchasing more sustainable products. So also this gender aspect is going to be tackled in this part of PRESERVE, also with some training activities that our partner European Bioplastic is going to organize. And so Christian, if you want to add something on this part.
Yes, of course. And in terms of thanks, by the way, for all the introduction, Aldo and Mara. And yeah, actually, especially for the working together and joining, this is also something that we as European Bioplastics, of course, do as our daily business. And therefore, we are very happy to provide our expertise to the consortium. And yeah, actually, especially as we are talking also about the standardization and yeah, actually the legislation processes in terms of standardization, European Bioplastics is of course already a part of this process, and being part of several of these ongoing initiatives and standardization committees on EU level as well as international levels. For example, the different Zen groups on bio-based or biodegradable plastics, or the respective environmental aspects that come with it, especially in terms of degradability and organic recovery of these packaging materials. And yeah, actually are also in charge, of course, for the EU-wide harmonized standard for biodegradation for EN 13432, and on international level in the ISO groups on bio-based plastics and biodegradable plastics, and of course in some national parts as well. So we of course keep an eye on all the frameworks that are leading into this, or that will be covered also by PRESERVE, and therefore it is even more interesting now to gain some more insights into our sibling project partners who are also working with this. So forming alliances here is crucial, of course, for us. And yeah, well, I'm also happy that our managing director is still here today. So if Hasso, if you want to add on something, if I missed out on anything for the standardization part, of course, feel free to join the discussion. I hope Pablo will be okay with that, because I think we are now going for the open discussion session. But in general, as I said it, the main or basic part is that we are already in terms of building alliances and trying to form bigger groups to work together on these topics. This is something that we already do, and are more than happy to yeah, expand this during PRESERVE, also with our sibling project partners.
Thank you so much, Christian. I just have one more a question to ask you, the three coordinators or the three projects, or something we could discuss. And it's this was the idea of Cristiano regarding the critical mass. If we could compare results, I would like to give the opportunity to Cristiano to talk about this point. Feel free, Cristiano, to ask the rest of the coordinators about this.
Thank you, Pablo. Yes, there is no doubt that the clustering of three big EU projects with such a large partnership, such large consortia is a huge opportunity, I would say. And I definitely believe in the fact that there's no silver bullet to solve the sustainability problem of plastic waste. So there is not one single technology who will solve it all. We talked already about it. Hasso already introduced it. We need mechanical recycling that is efficient. We need to complement it. We cannot mechanically recycle everything. What do we do with the rest streams? We need integration with chemical recycling. Chemical recyclings have still tremendous impact in terms of CO2 emissions, 100% more than mechanical recycling. So maybe we need to develop new biotechnological recycling that can complement. So there's definitely the need to reach critical mass, meaning that large consortia should work together, talk together, compare results. But how do we compare these results? And this goes back then to the need for clustering, I would say. And a very simple example comes from research and literature for those who work with plastic depolymerization and biotechnological recycling, let's say. If you look at all the studies working with PET enzymatic depolymerization, for instance, it is extremely hard to compare the different results with each other, because there's a lack of standardization in the sense of what type of plastic substrates we're using. It's PET, yes, but what type of PET? Is it highly crystalline? Is it amorphous? Is it a thin film? Is it powderized? Do we all buy it from the same supplier? Do we pre-treat it in the same way? If not, then the results that we get are really hardly comparable. And I believe also that this is a big opportunity for us to discuss internally among the projects and share the experiences, compare the methods and the protocols we use when we want to characterize. We want to say this is biodegradable, but how do we actually measure this biodegradability? How do we say, what conditions do we use to do the enzymatic depolymerization? If we can share these protocols and we can follow commonly agreed standard protocol, then we can compare the different technologies that come out, not only from one consortium, but from 3 consortia. And I also believe that this is an opportunity, because if you look in literature, each group develops their own methods, and they're all scientifically valid methods. But none has somehow the authority to convince all the other researchers to follow that specific method usually. But what if a consortium or a cluster of all the European projects that are working right now on plastic would reach critical mass and agree, well, this could be the best protocol to follow, we believe in this, then this would be credible and have the critical mass that is necessary to maybe also convince others to follow a similar protocol and make comparisons more doable, I would say, more realistic. So what we have done in the UPLIFT project was, inside of this were a package dedicated to depolymerization. We had internal meetings and trying to agree together that we can of course use different methods, different materials, but in the view of comparing the results, we wanted to have at least one type of material coming from the same supplier that was pre-treated by the same partner and then sent out to all the partners that were working on plastic depolymerization. And we agreed on following one specific protocol for depolymerization. That doesn't mean that we all do the same. We all develop different technologies, but then we have one reference. So we will all use our technology with the same type of plastic pre-treated in the same way in certain conditions that are comparable. And this will, of course, also facilitate then the LCA, the LCC, the techno-economical evaluations and the comparisons among them. So maybe this is then open to the discussion to hear also what the other projects are doing and if they would be interested or willing in finding together a shared approach so that we can even compare results across the projects.
So maybe Fuensanta, for example, would you like to give your opinion?
Yes, as I said before, we are working in some cases with similar materials. For example, we are working with PHA. We are obtaining a different kind of pH maybe, but the characterization of the polymer require a standard, a way of characterizing in the same way. For example, when obtaining the crystallinity, when analyzing the thermal properties, even rheology, because we are mixing this material with other material, we can develop a methodology to assess the rheology of the material. So there are some areas of working together when characterizing these biodegradable plastics. So our technical teams can work together in this area, or even prepare share papers regarding this methodology. And as you said, being able to get some standards to compare results, even when it comes to biodegradable materials like PHA. So yes, there is a very interesting area of work between us, yes.
Thank you, Fuensanta. And then I have just a last question. We are just 4 minutes to finish our workshop, but I would like to ask you, the three of you as a project coordinators, what are the expected results of each project? Because we know that the common goal that the three projects has is to contribute to upcycle the food and drink packaging materials, which account nowadays up to 60% of the market by 2030. But I would like to know your expected result, but if you can please briefly introduce the expected result of each project. And I think that could be a very nice way to finish and to conclude this workshop. So I don't know, maybe Aldo, if you want to start.
Yes, absolutely. Well, thank you very much. Just to add my opinion on the last question, from PRESERVE will be very happy to have also discussions on joining forces and to have a critical mass all together. Always thinking on the IPR involving and the partners interested of every consortium. Regarding the expected results of the project, well, I will just emphasize one very clear and probably the stand that we have in PRESERVE, which is the target we are having in terms of the entire package band of possibilities, and we are doing it in a way that 60% of the packaging that can be covered from our activities and our research involving flexible and rigid lids and different kind of packaging. So I would emphasize this from the PRESERVE initiative, and I will also associate this to the entire impact that this clustering is having in terms, very briefly, in terms of numbers. We are more than 68 different partners putting the three projects together from 19 different European countries, a budget altogether over the 20 million. So I think this would be the numbers to bear in mind by the end of the session.
Okay, Fuensanta, what about UPET?
Well, we are focused on upcycling polyethylene and PET waste. And our goal is to contribute as much as possible to the scope of the program, where we are. This project is in the European in Horizon 2020, and we are trying to contribute as much as possible as the upcycling of these two materials, even if they are mixed or if they are separated in the waste. But the idea is that our solution is a solution to these two kind of wastes.
Okay, and last, Cristiano, if you want to share the expected result of UPLIFT.
So I would say that for us it is to prove somehow that we can develop something that we could call a plastic biorefinery. So we said at the beginning that there are really large streams that are just used and thrown out and often end up in the environment. It's considered a waste, but in a biorefinery concept, we say that there is no waste. Everything can be used and converted into a higher value product. So if we can prove this on a TRL 6, so on a pilot level, we can on one side provide a framework that gives a value to this waste because it can be upcycled and converted into products that have a higher value. And at the same time, we can shift from a more fossil-based packaging materials to incorporating more and more bio-based ones by disintegration of bio-based building blocks. So we would like to show with a techno-economical evaluation that this concept, this model, is actually profitable and that it can contribute to reaching this goal of recycling more towards this 55–60%. And show also that an increase in the recycling will actually benefit the selling price of these new ecopolymers, meaning that if we recycle more, in principle, we should be able to have a lower selling price, so making them more competitive compared to the actual current market.
Okay, thank you, Cristiano. Thank you, all the attendees, all the speakers. It's already 1 o'clock. From my side, as I say, I'm truly glad to be moderating this workshop, but this couldn't be possible without the assistance and the proactivity of all the speakers and the people involved in this workshop organization. Thank you, all of you, one more time. As I said in the beginning, this webinar will be shared in our social media channels. So we invite you to follow UPLIFT, UPET and PRESERVE on LinkedIn and Twitter, and also to visit the respective websites. And I hope, as Mara said a few minutes ago, that this is just the beginning of a great collaboration. We hope to see you soon. Please do not hesitate to contact us in case you have any questions. Thank you so much and have a good week ahead.
Thank you,
everyone.
Pablo. Thank you,
Thank you.
everyone.
Thank you all.
Thank you.
Bye.
Bye.